Here's another good example of a volume of a rotation around a solids question. So determine the volume generated by rotating the curve y equals cos x between x equals 0 and x equals pi on 4 about the x-axis. Leave your answer in exact form. So first thing I'm going to do is I'm going to state the rule so that I can see what I need. Now, it's about the x-axis, meaning that volume is going to be given to us by doing pi times your lower and your upper bound multiplied by your function fx squared. Oh, this is going to be good. Okay, so volume is going to be equal to pi integrate between 0 and pi on 4 for your function cos squared x dx. Now, we can't do this straight away. We need to adjust our function by looking at our Pythagorean identities. Like I said, solid question. So if you flick over to the trigonometry section in your formula booklet, you'll see that we've got some double angle identities. So the one that we are going to be using, now I'm going to write this to the side so that you can see how I adjust it. So we've got cos 2a is equal to, now I've got a couple of other ones in there with squared, but I want the one that's only got the cos squared in there and the rest of it. So that is this one. Now the point of this is that it's going to stop it from being a squared trigonometric function into just being a standard one. So now I'm just going to rearrange what I've got so that I end up with cos a on its own, and then I'm going to substitute in over here. So cos 2a is plus 1. This will move first. Then I'll divide the whole thing by 2 to get rid of this, and that will leave me with cos squared a. Now, initially, our a was x, so when I replace it over here, I'm going to replace this function with cos 2x plus 1 all over 2. Okay, so let's replace that in our function now. So volume is equal to pi, integrate between 0 and pi on 4, bracket, cos 2x plus 1 all over 2 with respect to x. Now, the first thing that I'm going to do before I integrate to make my life a little bit easier is I'm going to take this part to the front. Both terms are being divided by 2, so that means that I can take it out the front and then it becomes a later problem. So that is pi on 2, integrate pi over 4, 0, and now I'm just integrating this function, which is nicer, with respect to x. So now I'm finally ready to integrate. Okay, so when I integrate my cos function, cos is going to go to a sine. So sine 2x, and when I take the derivative of this bracket, it's going to become 1 over 2. When I integrate 1, it's just going to turn into x, and then I'm going to substitute in my values of pi on 4 and 0. So now I've got pi over 2, 1 over 2 sine 2 times pi over 4 plus pi over 4 is going to make up my first bracket, and that's going to subtract my next bracket, which is when I substitute the 0 in. Sine 0 plus 0. Okay, so let's simplify some of these terms. So sine of 0, start by drawing my unit circle. Sine of 0 degrees is just 0, so this is cancelled out, so is this. When I'm looking at this section, that will cancel with that, and I'm left with pi on 2, which will be this position on the unit circle, and that is when our y-coordinate is 1. So this is equal to 1. So now I'm left with pi on 2 times a half plus pi on 4. Now, in your question, you might be required to simplify this further by expanding this into both of them, which would make it pi on 4 plus pi squared on 8. There's really a lot of different ways that you can simplify it. I'm going to stop there. You'll see if you look at their answers that they've gone to factorise one of the pi's out. You can do it. You get the same answer. It doesn't matter.